Hey everyone, Chang here and welcome to my channel. This is the bare minimum algebra series. Today we are going to focus on graphing linear inequalities. Now, it's actually built on graphing linear equations, so if you haven't gotten that down or you're not sure, please check out my other video. It has a step-by-step on how to graph a linear equation. Now, we're going to build on that and use that to graph linear inequalities. Now, with that knowledge, is actually only 3 steps with different if cases. If this happens, do this. If this happens, do this. So we're going to talk about each and every one of those cases. Total, there are 4 possible scenarios depending, right? And we're going to go over that. So first and foremost, to graph linear inequalities, it's actually very similar to graphing a linear equation. That's exactly the first step, right? So you solve for y like you would normally solve for a linear equation. For the inequality symbol, think of it as an equal sign temporarily. Just for the situation of solving for y, just think of it temporarily as an equation sign so it doesn't get confusing. Solve for y, you have it very similar to the format of slope-intercept. Y equals mx plus b. While the equal sign actually might be a less than, greater than, less than or equal, greater than equal, doesn't matter. Just make sure you solve it correctly so that it's something of this format, because the second step is what is really important. Once you get it into this format, you already have, once again, your m, which is your slope, and b, your intercept. And going through the steps, you're going to graph the line. Now here's one of those if cases. If it is a greater than or less than, right, without the equal, you're going to dot the line. So instead of drawing one solid line, like you normally would when you're graphing, you're going to make it a dotted line. If it is a greater than or equal, or less than or equal, then you're going to keep it a solid line. So you're just going to make sure you solid the line. Now, the last step is fairly straightforward, but can be confusing at times. You're going to pick a random point of your choosing, whichever you want, from one side of the line or the other. Don't pick it on the line, it doesn't help, right? You got to pick it either from one side or the other. Usually I pick a fairly simple one, and I'll show you that in an example. And then you plug it into the original inequality, whatever they give you. And then you solve. If that statement is true, then you're going to shade that entire region of that line on that side of the line, right? Because guess what? That means every single point in that region is true. If it is false, then you know that everything on that side is wrong. Then you shade the other side. Right? That's the other if situation. So 3 steps. An if situation here, if it is greater than or less than, dot. If it's greater than or equal, less than or equal, solid the line. The second if situation, if the random point you pick is true, shade that area. If the random point you pick is false, shade the other area. Wow, I'm having trouble talking today. All right, there we go. So let's look at an example, because that will make a whole ton more sense. All right, so I'm gonna go over 2 examples with a slight twist, just because most likely you will encounter different ways, different written formats that you really have to take into consideration. But overall, what you do, how you solve it, how you graph it, is exactly the same. So this one right here is lovely. Even though it didn't really look like our slope-intercept form, it really is. You have y on one side and everything else on the other. It just happens that y is on the right-hand side, and some of the students I've encountered freak out when they see that, right? It's okay. You can keep it that way if you want, or you can just rewrite it. Y is still smaller if you just forget the concept of greater than, less than, whatever. This is the bigger side, this is the smaller side. You can just rewrite it, and all of a sudden you have 2x minus 4. Now this is more closely to your slope-intercept format, and then now you can proceed to graph it, right? So once again, this is great. Start off right here. This is our intercept, which is -4, so it's going to be 1, 2, 3, 4. This is my first point. This is my slope right here, and in the other video I mentioned that there are times where you have a solid number instead of a fraction, right? And in this case you can just rewrite it as a fraction 2 over 1. So I would go up to 1, 2, and over 1 right here. Now, this is a less than symbol, not a less than or equal. So instead of making a solid line that I normally would do, I would make it a dotted line. Okay, there it is. Now I've graphed it. That's our first step, right? First and second step, technically, right? We solved. If necessary, we graph. Now the third one is we pick a random point and we plug it into the original inequality. If it's true, we shade that area. If it's false, then we shade the other area. Now, I mentioned that I am extremely lazy. Hopefully you guys got that by now. That's kind of the whole point of this bare minimum algebra series, to be lazy. All right, so what we can do in this case is pick a point that is the easiest to plug in to see if it's true or false. Me, personally, if the line is not on 0, 0, I'm gonna pick 0, 0 because that's the easiest. I'll plug it in and see if it makes sense. This right here, if I put in 0, that just becomes 0 because any number times 0 is 0. And then this one becomes 0 as well, right? 0, 0. So now I have -4 is greater than 0. Is that true? No, not necessarily. Hopefully you guys got that, right? So since that point was right here where I picked and I tested it out, it's not true, then I forget this entire side, I shade the other side, right? You shade this entire area, meaning that any point I pick in this area will make this statement, this inequality, true. That's how you would graph this one. Fairly simple. Now, this second example is slightly more challenging. Still the same, except it's not written in your slope-intercept format. So we got to solve this first, step 1. Here's your y. Now, there's a lot of different ways to solve it, but I really wanted to point this out because guess what? This is a common mistake. Even though I said think of this as an equal sign and solve it, right? That's just so that it doesn't cause any confusion. Remember, when you're multiplying and dividing by a negative number on both sides, you have to change the sign. So this is an example where it shows that. All right, so we have this. I'm going to solve for y like I normally would. So I'm going to subtract x first, subtract x, and all of a sudden I have -6y is less than or equal to minus x plus 12. Okay, now I'm going to divide by -6 on both sides. So that means I would have y, and this one, negative is positive, so it's going to be technically 1 over 6x, and 12 divided by -6 is -2, so subtract 2. The sign right here, this is the key, has to be switched, right? The reason for that is, once again, I am dividing both sides by a negative number. So originally it was less than or equal. Now I have to switch it to greater than or equal. Now, once we get to this, it's fairly similar to the first example, except for this time we have an or equal. So instead of a dotted line, we're just making a solid line. So graph again, fairly simple. This is our y-intercept, that's a -2. So it's gonna be 1, 2, starting right here, okay? And then now this is up 1, positive, over 6. 1, 1, 2, 3, 4, 5, 6, if I can count, right there. Hopefully you guys can see that, right? So in this case, instead of a dotted line, this is an odd angle. There you go, close enough. But basically it's supposed to go through those 2 points. So this is a solid line, okay? Once again, I'm going to pick a point. I'm going to test it out. I'm going to pick the lazy point, 0, 0. So is it going to be 0? 0, 0 minus 0 is 0. 0 is less than or equal to 12. Very true. So in that case, then I would shade this entire region. And then that's it. Plain and simple. All right, so there you have it. That is how you would graph a linear inequality. All right, so once again, it is built on graphing linear equation. Check that out, right? After that is fairly simple. Temporarily think of the inequality symbol as an equal sign, with the caveat that if you're multiplying or dividing by negative number, don't forget to switch to inequality. But outside of that, you're just solving it so that you get y equals mx plus b or a very close variation of that. then you graph. If it is less than or greater than without any correlation to equal, then it's a dotted line. If it has or equal in any one of those situations, then it's a solid line. Lastly, you just, after graphing, you pick a point on either one of those sides, and then you test the original inequality. If it's true, you shade that region. If it's false, you shade the other region. Now, here's the thing. I do have to emphasize this. If you pick 0, 0 like I tend to do, make sure that it is not on the line. Remember, when you're picking the points, you're trying to test which area, which side is the correct side. If you pick a point on the line, no matter how convenient it may seem, it doesn't answer the question, it doesn't help. So, if it doesn't work, if 0, 0 doesn't work, pick another point that is as simple as possible, that's not on the line, and then, go nuts. All right, there you have it. Hopefully that was as simple as it can get. 3-step technically to graph linear inequalities, and there it is. Thank you for watching. If you haven't already, please like, comment, and subscribe. I will see you in the next video.